this video, I'm going to talk a bit about how air source heat pump sizing affects efficiency. When variable speed heat pumps first came out, they have variable speed compressors, they can modulate over a wide range. Lots of people thought, oh, this is great, sizing won't be that much of an issue. Unfortunately, our research and many other people's research has found that sizing probably matters much more with variable speed heat pumps with efficiency than with one stage or two stage equipment. It is unfortunate, but sizing really plays a part with efficiency and sometimes with comfort. Oversizing can sometimes compromise comfort. Let's look at an example. This is kind of an extreme case. I'll show some of both extremes. This is a new construction passive house built in climate zone 5. You can see on the gable end there's one heat pump. There's one 1-ton heat pump that provides all of the heating and cooling for this home. It's a passive house home, so it's very extreme. And if we look at how the designer calculated the loads and selected the equipment, well, let's do that. Here's a chart. We have outdoor air temperature on the x-axis, when we have load on the y-axis. And this is the design load that the designer calculated for a design temperature of 0 degrees, 9,000 BTUs an hour. This wasn't me that calculated it. The contractor or the designer for this project calculated it. It's useful sometimes to draw a load line. I mean, load lines don't necessarily reflect real world conditions, but they still can be useful. So at 0 degrees, if your load is 9,000 BTUs an hour, at some warmer temperature, the convention is 65 degrees. Usually it's actually cooler than that. But at 65 degrees, the house does not need any heat at all. So that's your 0 point. And then you draw a line to connect them. And voila, a load line, which again is useful, but it's not something that reflects the real world, how the systems of the home operates in the real world. I said it before, I'll say it again. Load calcs are very, very conservative. We monitored the heat pump that was providing all the heating and cooling for this home. There was a single 1-ton heat pump that did it all, and this is what we found. Each dot on this chart is an hour, and this shows heat pump output. Each dot for that hour at that outdoor air temperature. We can see even down in the single digits, the heat pump never needed to put out more than 5,000 BTUs an hour. This was not because the heat pump was malfunctioning or faulty or there was some kind of error. It's because the house never needed more than 5,000 BTUs an hour. When we were actually installing our monitoring system and testing, making sure everything was working right, we actually saw the heat pump go up to 11, 12,000 BTUs an hour. But in normal operation, when the heat pump was just trying to keep the home at 70 degrees throughout the entire winter, the home needed no more than 5,000 BTUs an hour. Also, it's interesting to look at where like the zeros start. You know, in the low 20s, 30s, 40s, there are times when the heat pump just shuts off entirely. That indicates to me that the heat pump is probably cycling on and off, and inverter-driven heat pumps are much more efficient when they can modulate rather than cycle on and off. So in addition to not needing a lot of heat at cold temperatures, it started cycling on and off at still relatively cold temperatures. And that can compromise efficiency, as we'll see. First, I want to show what the manufacturer said that this heat pump could do. I had to change the scale for this one, but the purple line shows the maximum heat pump output per the manufacturer. Down in the single digits, the manufacturer literature says this heat pump can put out 12,500 BTUs an hour. And again, the home never needed more than 5, so the heat pump is 2.5 times higher capacity than it needed to be. When we looked at efficiency, the COP for this system was 2.0 for the whole winter, the whole heating season. Lower than we would like. These COPs for these systems can be near 3. 2.5 to 3 is a good target range. Even above 3, I've seen systems perform with seasonal heating COPs above 3. Totally possible. The main reason the COP was much lower than we would like is because of sizing for this system. Let's look at one other example. This is not a new passive house. This is a 100-plus-year-old leaky farmhouse. This is actually in Western Massachusetts. The owner here, the home was heated hydronically with baseboards and radiant floors. The homeowner wanted to put a heat pump in one space to provide some cooling and to supplement that. Here's a similar chart for this home. Again, we have outdoor air temperature on the x-axis for that hour, and then we have heat pump capacity and output on the y-axis. That purple line is the maximum heat pump capacity from the manufacturer, and each dot shows an hour during the winter and what the heat pump was putting out. Less than half, with few, if any, exceptions, the heat pump was putting out less than half of its rated capacity. And the reason for this is this was a 1.5-ton heat pump. The load calculation, I did not show the load calculation here because nobody did a load calculation. 1.5 tons was the biggest capacity in the product range, and bigger is better was the rationale, I think, for this one. So they put in as big a heat pump as they could, and it never put out more than half of its maximum capacity. Again, the overall winter COP for this heat pump was 1.6. That's almost half what we would like to see. We would like to see COPs pushing 3, and this is well under 2. Not great. One more example. This was the same exact model of heat pump, 1.5-ton ductless heat pump. This is installed in a home in near Burlington, Vermont. Colder temperatures than in northwestern Mass. Same exact model for the heat pump. And this home was undergoing a pretty dramatic deep energy retrofit, kind of pushing passive house. But it was in progress. All the renovations had not been completed when we monitored for this winter. It was still a work in progress. There was still work to be done. We see the heat pump, all those blue dots are the heat pump output. We see the heat pump output well above what the manufacturer says is the maximum capacity for the heat pumps. And we've seen this again. I totally trust what manufacturers say for their maximum capacity. I've seen it hit the maximum capacity. I've seen it exceed the maximum capacity as it did in this configuration. Because this was a work in progress, I think this heat pump was actually undersized for the application. So, not ideal, but very interesting to look at the points. And also look at where the heat pump turns off. The heat pump doesn't turn off until temperatures go up into the high 30s Fahrenheit. So it does not cycle on and off until temperatures get up, well into the 30s or 40s. Very different picture from where we saw the oversized system shutting off at much, much colder temperatures. The overall COP for this system was 2.4. Not up in that 2 to 2.5 to 3 range. There were a couple other factors going on in this house that may have compromised that. Actually, being undersized might have been one of those factors that kind of dinged the performance. It might have been struggling, especially during cold weather, to provide all the heat. But still, this more properly sized heat pump, maybe even undersized heat pump, was considerably more efficient than both of the other two examples, which were pretty dramatically oversized. Just to sum up quickly, variable speed air source heat pump sizing really has a big effect on efficiency. Putting in much more capacity than you need really can lower the overall efficiency of the system. I'm lucky in that I've monitored a bunch of these systems in homes. I've seen firsthand that the manual J calculations, even really aggressive manual J calculations, not, no buffers anywhere, are still very, very conservative when it comes to what the actual heating needs of the home are. I encourage people to to prove it to themselves. You know, dig in and see how your systems are performing. I'll show some more examples in future videos. In the next video, we'll talk about multi-zone systems. But sizing is very important to get the best efficiency out of air source heat pumps.